In today's class, we will solve this second major exam of term 232. We will try to solve as many questions as we can. There are 18 questions. I doubt I would be able to solve all of them, but let us try to solve as many as we can. For this question number 1, this is, as we can see, Weibull distribution. This is from chapter 4. The question says that assume that the life of a roller bearing follows a Weibull distribution, and the parameters of Weibull distribution are directly given to you. Beta is given to be 2, delta is given to be 10,000. Determine the probability that a bearing lasts more than what? More than the mean. So there are two things to identify in this question. First thing you need to identify is the mean of this distribution, and then you need to identify what is the probability of x being more than its mean. So let us first write down what is given in the question. Given in the question is that x follows a Weibull distribution with beta equals 2 and delta equals 10,000. And you are required to find the probability that the bearing lasts more than its mean. So before you find this probability, you need to find the mean. And to find the mean, where will you go? You will go to the formula sheet. And when you go to formula sheet, you will find the formulas related to Weibull distribution. Which one is Weibull distribution? Here are all the continuous distributions. Which one is this? Exponential. Which one is this? Weibull. Which one is this? Lognormal. And which one is last? This one? Normal. Normal. So it's exponential, Weibull, lognormal. I don't think you will use this first line. You will use the mean and variance only for the lognormal. So for the Weibull distribution, mu is what? Mu is what? Delta multiplied by gamma of 1 plus 1 over beta. So I will take this formula and I will write it here. Mu equals delta multiplied by, not square root, gamma of 1 plus 1 over beta. Is it correct? Okay. So what was delta in your question? 10,000 multiplied by gamma of 1 plus half. Trouble question. We know that the gamma of integer is integer minus 1 factorial. And we also know that gamma of any number is equal to number minus 1 times gamma of number minus 1. Now, how do you open this gamma of 3 by 2? This is gamma of 3 by 2. So this is 10,000 multiplied by 3 by 2 minus 1, which is half multiplied by gamma of half. You open it with the recursive property of gamma function. Using this property of gamma function, alpha gamma is alpha minus 1 multiplied by gamma of alpha minus 1, using this result. So 5 by 2 gamma is 3 by 2 times 1 by 2 times 1 by 2 gamma. So you keep opening until you reach 1 by 2 gamma. 1 by 2 gamma is what? Again, another result. The thing is that none of this information is given to you in the formula sheet. You need to know this. You need to know this. None of this information is given in the formula sheet. So this becomes 10,000 multiplied by 1 by 2 multiplied by square root of 5. And the mean comes out to be 5,000 multiplied by square root of pi. Then this probability, can we find the greater than probability directly using CDF? No, we have to convert it to 1 minus. So this is 1 minus capital F of mu. So plug it in and you will have 1 minus, what is capital F for the Weibull distribution? It is 1 minus e to the power minus x over delta to the power beta. So here is my x over here is my delta to the power, what is my beta? 2. Solve this on calculator and you will get 0.45594, which corresponds to option A. It is a very tough question. This is an A+ question with 2 tricks in it. Number 1, you need to find the mean of Weibull distribution. Number 2, you have to find area greater than the mean of Weibull distribution. Another question you might expect from here. Is this distribution positively skewed, negatively skewed, or symmetric? You find the median, you find the mean, you compare the two of them, and as there was a question in major 1 also for symmetric distribution, mean is equal to median, correct? For positively skewed distribution, it's the median less than mean. For negatively skewed distribution, it's median greater than mean. Q1, Q2 is tough. Mean and median is easier. So find mean and median and check the skewness using mean and median. You can also check it with Q1, Q2, Q3, IQR and all that, but that's much longer. Find the mean and median and check the skewness from there.
Can I find the gamma using calculator?
Does it give you?
I don't know, yes.
If it does give you, nobody will stop you from finding gamma on the calculator.
There was a way.
I don't think in standard calculator, no, but maybe advanced calculator, yes. But as far as I know, advanced calculators are not allowed in exam. How can we know that it's the advanced calculator? The proctor might check. It's a risk.
Watch is only the half.
Half what?
The fractions with the gamma.
Here is the result. If you want gamma of 9 by 2, this is 7 by 2, 5 by 2, 3 by 2, 1 by 2 multiplied by square root of pi.
Is there something wrong?
Yes, there is, but it's not in your syllabus.
The syllabus only.
Syllabus only for either gamma of integer. This will be simply integer minus 1 factorial. Or we give you gamma of odd integer divided by 2. Those are only 2 cases. Either gamma of integer or gamma of odd integer by 2, because gamma of even divided by 2 will again go back to integer. If you divide even number by 2, you will go back to the integer. So gamma of odd integer by 2 will be number minus 1 times gamma of this, and you keep opening until you reach half gamma. When you reach half gamma, substitute it by square root of pi. Second question, this says that the time between the arrivals, at a taxi at a busy intersection is exponentially distributed. Again, this is a question from chapter 4, exponentially distributed. So you have x that follows exponential distribution. With a mean is given. What is the mean of exponential distribution from the formula sheet? You have 1 over lambda. So 1 over lambda is given to you, not directly lambda. Mean is 10, which means lambda is 1/10 per minute. Then the median is what? How do we find any percentile for any distribution? F of yes. F of P alpha equals alpha by 100. Solve this equation for P alpha. So F of median equals 0.5. What is F of x for exponential? It is 1 minus e to the power minus lambda x equals 0.5. Solve this equation for m. How do we solve this equation for m? Take this to the right side and this to the left side. And you will have what? E to the power minus m by 10 equals half. Then take the ln on both sides. You will have minus m over 10 equals ln of 0.5. And then this implies m is minus 10 times natural log of 0.5. And this will be a positive number. Remember, exponential is time. Time cannot be negative. This will be a positive number because ln of 0.5 will be negative multiplied by negative 10. This will be something positive. Again, if you get a question from exponential distribution to check the skewness, what will you do? What is the median? Can someone? Okay, I have it. It's 14 point, no, it's 6.93. 6.93. Now, what is the mean? 10. What is the median? 6.93 or something close to 7. Mean is greater than median. In this case, the distribution is skewed to the right. Skewed to the right. But remember, exponential distribution is always skewed to the right. Whatever is the lambda, exponential distribution, it decreases exponentially like this. It is always skewed to the right. So you can answer this question even without solving. Just any exponential distribution is always skewed to the right. Question number 3. Read this question. What was the option? Correct option? Approximately 6.9 E. Question number 3 says, a manufacturer of electronic calculators takes a random sample of 1,200 calculators. And he finds that 100 out of those 1,200s, they are defective. So the sample size here is what? 1,200. Number of successes is what? Number of successes, remember, is the category that you are interested in. So read the remaining question. Are you interested in confidence interval of the proportion of defective or non-defective? Non-defective. So here, your x will be number of non-defectives, not number of defectives. So what is x in this case? 1,100. Because your interest later is in non-defective. So P hat is what? P hat is, let's keep it like this, 11 by 12. And the formula for 95% confidence interval for P is given in the formula sheet as P hat plus minus Z alpha by 2, P hat 1 minus P hat over N whole square root. The only thing which is left is Z alpha by 2, which is a popular value. Your alpha is 0.05. Alpha by 2 is 1 minus alpha by 2 is, so Z alpha by 2 will be, so you just plug it in, 11 by 12 plus minus 1.96 square root of 11 by 12, 1 minus 11 by 12 over 1,200. What was required? The length. What will be the length? Either you find the two limits and then upper minus lower will be the length, or you just take the twice of this thing. Both ways should be okay. You find this one, and then U minus L will be the width or length. Or you can simply find the length of interval. It will be 2 times 1.96 times square root of this. Both of them will give you the same answer, and that same answer will be 0.30313, corresponds to option B. Any questions so far? Again, what was the important task in this question? To identify that it is a confidence interval for the proportion. Once you identify it is for the proportion, then you need to just sync the value of x with what is required. Question number 4. From a normal population with unknown variance, this is very important information. Unknown variance, the confidence interval for the confidence level for this interval is what? You are given a confidence interval, which is x bar plus minus 1.325 multiplied by s over square root of 21. This means t alpha by 2 with v degrees of freedom is 1.325. They are asking you what is the value of 1 minus alpha, not alpha. They are asking you to find the value of confidence level, not the significance level, confidence level. Now, to go to the t table, you need v. What is v for t distribution? N minus 1, which is 20. Go to the t distribution with 20 degrees of freedom and see that what is the value of alpha by 2 against 1.325. So let me go to the t distribution. With 20 degrees of freedom. With 20 degrees of freedom. Do you see 1.325 exactly? What is the value of alpha by 2 against this value? 0.1. This is alpha by 2, remember. This is alpha by 2. So from the table, we have alpha by 2 equals 0.1, which means alpha is 0.2, which means 1 minus alpha is 0.8, which means D is the correct answer. Question number 5. A normal population has mean 137. Again, important information that X is normal, number 1. Its mean is 137, number 2. Its variance, not standard deviation. Variance is 36. How large must the random sample be? The question is about estimation of sample size. How large the sample must be. So there were 2 cases of sample size estimation we took in chapter 8. 1, estimation of sample size for proportion. 2, estimation of sample size for mean. The formula for estimation of sample size for mean given in the formula sheet is something like this. This is given in the formula sheet. So once you recognize that this question is about estimation of the sample size for population mean, you need to search in the question for these 3 components: Z alpha by 2, sigma, and E. Search for these things in the question. So what is E? Oh, E is not given directly. What is given? Interesting. What is given? You need to know this terminology. What is standard error of X bar? Look at this slide. Need to know all of these terminologies. What is 1 minus alpha? Confidence level. What is alpha? Significance level. What is Z alpha by 2? Critical value. What is sigma? Population standard deviation. What is sigma over square root of n? Standard error of X bar. What is Z alpha by 2 times sigma over root of n? Margin of error. What is 2 times margin of error? Length. So standard error of X bar is what? Sigma over root of n. This is given to you. Sigma over root of n is given to you as 1.2, and sigma is also given to you. What is sigma in the question? 6. So this means square root of n is sigma over 6 over 1.2. This implies n is 6 over 1.2 whole square, which is 4. $25. Unusual question. It was about the estimation of sample size, but error was not given to you. Standard error was given to you. E was not given to you. Sigma over root of n was given to you. Again, terminologies. Mean was given to confuse you. Did not use the mu anywhere in the question. Question number 6. Read it. The resistance of resistors of a certain type is a random variable having important information. Normal distribution. What is the mean? 9. What is the standard deviation? 0.4. A resistor is acceptable if its resistance is between 8.6 and 9.8. If X is between 8.6 and 9.8, it's acceptable. What is the probability that out of 4 randomly selected resistors, sample mean is acceptable? What is the question? What is the probability that the sample mean is acceptable? When will it be acceptable? If it is between? This is required in the question, that the sample mean is in the acceptable range. That is, it is between 8.6 and 9.8. How do we find any probability related to the sample mean? Chapter 7. Any probability related to X, if it is normal, you solve it using this formula. Any probability related to X bar, you solve it using this formula. Chapter 7. So convert it to first less than. This will be equal to probability of X bar less than 9.8 minus probability of X bar less than 8.6. Convert it to 2 separate less than CDF types. Then transform it to Z. This will be probability of X bar minus mu divided by sigma over root of n. 9.8. Mu is what? 9. Sigma is what? 0.4. N is what? 4. Minus similarly the second one. Okay. This will become probability of Z less than 4 minus this will become probability of Z less than minus 2. Go to the Z table and look for probability of Z less than 4. This will be an interesting situation. I'll show you. What is the probability of Z less than 4. No, 4 is available in the table. I thought it would be out of the table. What is the probability of z less than 4? Now, imagine a situation where we ask you to find the probability of z less than 5, which is not available in the table. What will be the probability of z less than 5? 1. Remember how to obtain the value of z which is outside this table. What about probability of z less than minus 5? What is the last available value in the table? Minus 4.39. This is already almost 0, correct? So less than minus 5 will be even smaller than this one, which is almost 0. So remember, you can have a value of z outside these minus 4.39 and plus 4.39. In that case, the less than probability will be either 0 or 1. If it is on the left tail, it will be 0. If it is on the right tail, it will be approximately 1. So for this case, luckily 4.00 was available, 0.99997. Minus, this is 0.02275. And the answer is 0.97722, which corresponds to D. Any question? Yes.
But you didn't mention that it is independent. What would be?
For dependent samples, we did not take anything related to finding the probability of sample mean when the observations are dependent. It will be independent. If it says random sample is always independent observations. No, you cannot have a random sample where the observations are dependent upon each other. If they are dependent, none of these theories starting from chapter 7 onwards, it applies. None of them.
Is it?
Real world, it is independent. For example, if I pick 10 students from this class and ask them their score in major 1, the observations are independent of each other, of course. Question number 7. Read the question. The yield of chemical process is being studied. From previous experience, yield is known to be normally distributed with unknown standard deviation. Important information. Unknown. This is pushing you towards T probably. The past 5 days of plant operation has resulted in the following values of yield. Now, here they give you the sample. And they ask you to compute a 95% confidence interval on mu. Use 3 decimal points in your calculation. So a 95% confidence interval for mu when sigma is unknown, it is equal to what? So you need to find these quantities from the question, all of them, 4 of them. From the question, they gave you the sample, and the sample mean will be, you compute it using your knowledge of chapter 6, that will be 90. The sample standard deviation, again, the sample was given to you. You will use your knowledge of chapter 6 to find the standard deviation, and that will be 1.118. Sample size, what is the sample size? 5. Then alpha, what is alpha given to you in the question? 0.05, alpha by 2. Will I take 1 minus alpha by 2? For T table, no. For Z table, yes. That's the difference between Z and T. When you go to Z table, you do an additional step of doing 1 minus alpha by 2. When you go to T table, you look for alpha by 2, not 1 minus alpha by 2. So go to the T table, 4 degrees of freedom, and look for 0.025. Look for 0.025. T table, 4 degrees of freedom. Four degrees of freedom and look for 0.025. What is the value? 2.776. So T 0.025 with 4 degrees of freedom is 2.776. So take everything, plug it in. It will be 90 plus minus 2.776, 1.118 over square root of 5. And this will correspond to 88.612 to 91.388. Option C. Rounded up to how many decimal points? The question says 3 decimal points. Question number 9. What? 8. The lifetime in hours of 75-watt light bulbs is known to be normally distributed with standard deviation 25. A random sample of size what? 20. Gave me a mean of 1014. The margin of error for a 99% confidence interval for the mean is what? What is the formula? Again, that slide I showed you from chapter 8. What is the formula for margin of error? In this formula, what do you need? You need sigma. Is it available in the question? Yes. You need n. Is it available? Yes. You need z alpha by 2. Is it available? Alpha is available. So you can find it through alpha. This is to confuse you. Alpha is 0.01. Alpha by 2 will be 0.005. Let me do it. So z alpha by 2 will be 2.575. Now in exam, if you take 2.58, it's okay. 2.57, it's okay. So margin of error will be 2.575 multiplied by sigma is 25 divided by n was 20 square root. So this should be something, 14 point something. Okay. Question 9, probably just a statement question. The population of soft drink cans filled by a particular machine is known to be normally distributed. Just look at the proportion of questions from normal distribution so far. How many questions they came from the normal distribution? I think more than half so far. So the population of soft drink can filled by this is normally distributed. The mean of this distribution, can anyone tell me if this is a sample mean or population mean? How do you know that? It's the statement talking about the distribution, and the distribution is population. And the standard deviation is, if a sample of 25 is selected, which one of the following is true? I will tell you why each statement is not true and why one of them is true. The sample mean has a t distribution. Is sigma known? Is sigma known? So it follows z, not t. So this is wrong, not t distribution. In case of unknown sigma, it goes to t. In case of known sigma, it goes to z, which is normal. We cannot tell. I might not be able to tell if the other options are also wrong, but I'll have to wait. See, the sample mean has a normal distribution. This is true. With mean 12, was the mean of x also 12? So sample mean x bar is also mean 12. What about the standard error? Sigma over root of n. So my sigma is 0.25 over sample size 25 square root. So this will be 0.05. 0.05. So this is wrong. Standard error should be 0.05. Normal distribution is correct. Mean is correct. Standard error 0.25 degree of freedom. No, wrong. Mean is 12. Standard error is 12. Distribution is normal. This is correct. So also this is incorrect. We cannot check the option that we cannot tell. We can tell that option E is correct. Normal. Z is normal. Z is a special case of normal. We call it standard normal. If there was unknown sigma, you might look for T.
Does T consider?
No, T is not normal. T is T. An electronic company manufactures resistors that have a mean resistance of 100. Mu is 100. And the standard deviation is 10. The distribution of the resistance is normal. Find the probability that a random sample of 25 resistors, they have a total resistance of less than 2375. Interesting question. The question is not about the sample mean. The question is about interesting question. The question is about sample total, not sample mean. What is sample total? It's the total. What is the total? Total is the total. Sum of all the values. So the question is about summation x, not about x bar. The question is find the probability that the sample total is fewer than we haven't done anything in our slides related to summation x. We did everything related to x bar. Can this question be converted to x bar? How? Divide both sides by n. N is what? 25. So the question will become probability of x bar less than, this was question electronic. It will become 95. And then how do we solve any question related to x bar? What is mu? 100. What is sigma? 10. What is sample size? 25. So this will give you probability of z less than minus 2.5. Go to the z table. Look for the area below minus 2.5. This should be 0.00621. That corresponds to option C. Interesting question. 11. The probability density function of the weight of packages delivered by a post office is this. The PDF of X is given. This is chapter 4, general case, where X does not follow a specific distribution, no exponential, no Weibull, no normal, no log normal, this distribution with no specific name, general case. What is the average of shipping cost? Shipping cost is actually the weight multiplied by 2.5. So we are defining X to be weight, number one, and we are asked to find the expected value of 2.5 times X, because the shipping cost against each pound is 2.5. So this will be equal to 2.5 times expected value of X. And now you find the expected value of X. What is the expected weight of the package? From what to what? From 1 to 70, X multiplied by 70 over 69 X square dx. So you solve this integral. This will be 70 over 69 X cube. What is the integral of X cube? So this will be 70 over 69 multiplied by 4, 70 to the power 4 minus 1 to the power 4. I think there is a mistake here. X square is in the denominator, if I'm not wrong. Yes. While I was converting this exam into LaTeX, this one I wrote. This should be 69x square here. 69x square. So this should be what? This should be integral 1 over x dx. 70, 69. So log of 70 minus log of 1. And then you have to multiply. The final answer will be 2.5 multiplied by this is going to be 4.31. So this is going to be 2.5 multiplied by 4.31, which corresponds to 10.77. So you find the average of X multiplied by the shipping cost against each pound, and that's the expected shipping cost. Question 12. A random sample has been taken from a normal distribution with known variance. Remember, this is a very interesting question again. Known variance. That means the confidence interval computed is using Z or T? Z. Remember this kind of information, known variance, unknown variance. And they computed the following confidence interval for mu. There is this one interval and there is this another interval they computed. These are two intervals with different confidence levels. Then they tell you that this one is 95%. That means for this one, the value of Z alpha by 2 was this was the value used, 1.96. Then they are asking you what is the level of confidence for the other one. How do we solve this kind of question? First, find the width of the first one. The width of the first one is what? For any confidence interval, you need X bar. Can we find X bar from any confidence interval? How do we get the confidence interval? How do we move from point estimate to an interval estimate? Move a little right, move a little left. What if I give you an interval estimate and ask you for the point estimate? Where is the point estimate in comparison to the interval estimate? Right in the middle. So the value of X bar is take the average of any of these two intervals, that will be X bar. So take the center of one of these intervals or both of these intervals. X bar will be 3215.7 plus 3124.9 divided by 2. First, get the value of X bar. Okay. Then For the first interval, 95% confidence interval, the upper limit is actually x bar plus 1.96 times sigma over root of n. And this is given to me as 3215.7. Okay, this is given to me 3215.7, the upper limit of 95% confidence interval. From this, solve for sigma over root of n. This will be 3.2, not 3 point something, 3215.7 minus x bar. You found x bar divided by 1.96. Now you have all the components. Now they are asking you to find the confidence level of the second one. Again, find the width of the second one. Get the value of z alpha by 2 from the second one by plugging in this z alpha by 2. From this second one, the width of the interval is what? E is what? Which is z alpha by 2 times sigma over root of n. This is equal to width divided by 2. Okay. From this E, from the first interval, you got sigma over root of n. Okay. Plug it in. You will get from the second interval z alpha by 2 will be equal to square root of n over sigma multiplied by w over 2. You will get the value of z alpha by 2. From this z alpha by 2, now you will go to the z table and you will get the value of alpha. Very, very, very complicated question. Very complicated question. Probably A+ question, this one. So we were able to solve 12 questions in this class. Next class, inshallah, we'll have the quiz.